peasants off of it if they see that as in their advantage, if they wish to. And what you got was a lot of aristocrats deciding, I'm not going to have peasants growing food on this land anymore because it would be more profitable for me to get rid of the peasants and raise sheep and sell the wool from those sheep into these booming mills. And this cut labor free from the land. Those laborers, by and large, migrated to cities and began working in those factories. So these are you see that this is not a simple matter. There are a lot of contributing factors. There are legal and political ones, there are economic ones, there are technological ones that make this, that pull together this collection of circumstances in which this system can emerge. So, Weber. With the 19th century, production was freed from the organic limitations in which nature had held it confined. At the same time, however, crises became an imminent factor of the economic order. The social order itself may be held responsible for the crisis, even to the poorest laborer. I want to emphasize two things here about this passage. I think this is an important analysis of what happens in the 19th century. The first is in the first part, freed from the organic limitations in which nature had held it confined. What does he mean by that? Any idea? There's a very specific thing. It is about technological inventions, but he's talking about a very specific thing here. He's talking about energy. He's talking about coal. He's identifying a point in time at which coal enables work to be done on a scale that had not previously been possible. And this is precisely because it is concentrated energy. And the technology, I mean, that it was constant, that you could burn coal had been known for hundreds and thousands of years. But it could be, as of the 19th century, used in industrial processes that were technologically enabled and enabled vast amounts of work to be done that previously had to be done either by the force of water falling over a mill wheel, or by animals, or by people. That was their source of energy for work previously. And then the second is this part about crisis. He says, crisis becomes imminent to the economic order. So the social order becomes responsible for the crisis. And previously, if there was a crisis of production, it was typically due to drought or some climatic variation, some pest, locusts, who knows. There was certainly the possibility of crises in production, but they were essentially outside of the social order. There was nobody you could specifically blame. Sure, under previous systems, you might be able to point to the rain-making spirit mediator and say, wait a minute, you were supposed to bring the rain. But that is not an option here anymore. We all know better than that. That's irrational. Now, if there were to be crises in the system, they were not going to be about drought. They were actually going to be about the economic system itself. They were internal to the economic system. And we'll come back to that, provided I have enough time, by the end of the lecture. These two things are extremely interesting and important components of capitalism, and it's interesting that they are present here in Weber, rather than only in the writings of, say, Marx, who's known as a critic of capitalism. Weber is known basically as an analyst of capitalism, and he sees these things as intrinsic to capitalism itself. So here, we have some images of early coal mines being tended. I think that's intended to be actually an elderly woman simply lighting up the shafts, right? Towns that became choked with the soot and pollution of these early mines and mills. The construction of factories and apparatuses on a massive mechanical scale. British coal production skyrocketed in the centuries leading up to the Industrial Revolution. Tenfold increase from 1550 to 1700, up to 3 million tons per year, or half a ton per person. Probably 5 times greater than the rest of the world combined as of 1700. 4/5 of world production was coming out of England in 1830. And it expanded another tenfold from 1700 to 1830, and then doubled again in the next 24 years. England had a lot of coal. And they figured out ways to mine it and use it much more efficiently than before. And that is because they discovered ways to use it as a source not just of heat, not just of warmth, to warm your house or cook your food, but as a source of motive power, to convert heat into motion, work. So how does this work? You burn the coal, it releases the heat. You heat water, boil it, and it becomes steam. The steam expands. When steam cools, it contracts, the opposite, right? And that creates a vacuum if you've got it in a closed container. The air pressure created by this expansion and contraction can be made to move a piston. And then that piston, in turn, can move a wheel, for example. This is internal combustion, basically. There was a machine, the previous machine for doing this, Thomas Newcomen's atmospheric engine, was first installed in a mine in 1712 and was widespread by 1760. And this is, why was it installed in a mine? Why would you first think of putting a steam engine in a mine? Any idea? No? Well, first of all, there's a bunch of coal there, right? So it's not hard to get the coal you need to power the engine. Coal is heavy. It's expensive to move. It's convenient not to have to move it very far. Second of all, the biggest issue, as production expanded, exponentially, the biggest problem they faced was water, filling the mines. You dig a hole in the ground, you pull out the coal, eventually you're going to hit the water table, and the mine is going to fill up with water. And this was seen as a threat, literally, to the nation as a whole, because you had to get that water out in some way in order to keep digging. And this was an engine that could pump water out of mines rapidly enough to keep ahead of it coming back in and enable you to keep digging further for more coal. And that's basically what this engine was used for, because it was actually too expensive to use it for much of anything else, because this engine wasn't very efficient. It used enormous amounts of coal, and yeah, you're doing this to enable more coal production, but if you use so much coal pumping the water out that you don't get any extra coal for the effort, it's not worth it, right? James Watt's steam engine was not a new idea. It was just an improvement on Newcomen's idea, but it was an enormous improvement. It enabled the loss of the heat in cooling the steam to happen separately from the heating of the water where you were producing steam. It separated those two things out, so you didn't lose all that heat and have to put it back in to get the next batch of steam, basically. He was working with backing from an industrialist. There had to be an R&D budget even back then to support the figuring out of this technology. He was working with a craftsman, John Wilkinson, who was particularly skilled, sort of the best in the world at his craft, which enabled them to produce the actual machinery to a level of quality that would make this work, but it increased energy output per unit of coal by 400%. And this meant that it was now economical not only to keep pumping water out deeper and deeper and deeper and get more and more coal out of the ground, but it also meant that you could put these machines in factories, and the work they could do in those factories more than covered the costs of getting the coal there to power the machines, which was key. That was the real key. Previously, coal was so heavy and so expensive to move, and the engines, the Newcomen engine was so inefficient that it didn't make economic sense to use coal to power factories. With Watt's machine, it did. It made coal cheaper, and it made the use of coal to power factories profitable. And the Industrial Revolution really takes off from those circumstances, aimed not just at wool production, but then at cotton production, spinning, weaving, producing, and then manufacturing clothing from the cloth that resulted. Coal also enabled power and transportation systems on a scale previously unknown. The production of iron was made vastly more efficient and cheaper by the production of coal, or rather by the steam engine and its ability to use coal to produce energy and motive power. And you get a period of enormous canal building that is also made possible by the steam engine. Now, I don't have time to tell every last story related to these slides, but just to run you through some of the innovations that followed that sort of continually found the weakest or most inefficient point in a production system. Effort was focused on improving the technology to unlock that bottleneck, and they all sort of fed on each other. The spinning jenny, the steam-powered mule, the power loom, and finally the cotton factory. One cotton factory like this could be powered by a single enormous steam engine that simply ran a series of belts and cables so that each one of these looms could be powered by these belts coming down that were being turned by a shaft. These shafts were all connected to a single steam engine. And this enabled economies of scale and scales of production that were vastly larger than anything seen before. The cotton gin, a way of making more efficient the removal of seeds from raw cotton so that you could produce more cotton. There was a bottleneck at one point simply that the machinery was there, but you couldn't get enough cotton fast enough to feed all of the mills. You get even bigger factories. Child labor becomes a major issue as a lot of these jobs are held by children. Manchester is the center of this early industrial revolution. You get a powerful connection to the United States. Cotton production in the U.S. South skyrockets from $5.2 million in 1800 to $75 million just 40 years later, and almost double that again a mere 10 years after that. The number of slaves grows in connection with this. The overall U.S. cotton production goes from 3,000 bales in 1790 to 4.5 million bales in 1860 to feed these mills. You get a lot of land consolidation in the southern United States. The yellow areas here are areas where, of all farms, more than 10% were larger than 50 acres in size. And the red areas, they're between 5 and 9%. That's a significant thing, right? If even only 10% of farms are that large, each one of those landowners is controlling a significant amount of land. There might be a lot of smaller farms, but the overall landscape is essentially dominated by these large sort of industrial scale plantations. This also helped drive the displacement of a lot of native peoples, the most famous being the Cherokee. This is the Trail of Tears, the movement, the forced movement of the Cherokee from their native lands in the southeast, eventually all the way to Oklahoma. Their original land claims covered a great deal of the southeast. They began to shrink even by 1790. By 1838, they were this small, and they eventually ended up being forced to march all the way to Oklahoma, essentially to make way for the production of cotton in the southeast. This is also going on elsewhere in the world. This is India, of all places, where there's also significant cotton production being undertaken at this time, again, to feed the mills in the United Kingdom. Canals. Oh, man, how many people really need me to demonstrate using search engines on the library website? 1, 2. OK. Should we do that for the last 10 minutes instead of this? Or should we wrap this up? All right. If it's only that many people, I would encourage you to ask your GSI to help. I was going to basically ask one of you to provide your idea for a paper topic, and then I was going to run a few searches and show you how easy it is to do. But I think I'd like to finish this. Is that agreeable? OK. The Erie Canal was built between 1817 and 1825. It was made possible by steam engines to excavate the earth. It went along with railroads that were built in conjunction with the construction of the canal, and it enabled the movement of goods between the Great Lakes and the St. Lawrence Seaway and New York. Now, when this was first undertaken, it was basically paid for with European capital. And it was considered at the time something of a risk, but it turned out to be extremely profitable because it enabled trade from the interior United States on water rather than over land over the Appalachian Mountains, right? It opened up the interior of the United States to eastern markets through New York City. It helped make New York City into an enormous shipping terminal. And they not only made money, and not only other people who made money, but the investors in the canal made money as well from the various kinds of tolls they could charge for boats, for barges to float through on the canal. And this became an important moment because when the capitalist investors realized how much money could be made in canal building, they went elsewhere and did more of it. And it also helped trigger the boom in railroad production because it was, as soon as you got a canal and a railroad running next to it, it wasn't long before it was discovered that if the railroad could be improved and if locomotives and trains could be improved, they could be even faster than water as a way of moving goods. You see an enormous ballooning of the earnings of U.S. railroad companies after the Civil War, and the building of mileage of railroad track from 93,000 miles to 150,000 miles in a 40-year period of time. You see an enormous growth in the ton miles of railroad freight. The building of the Suez Canal between 1854 and 1869 was an even larger example of the same idea. It cut travel time between England and Eastern Asia in half. It bankrupted the Egyptian government, which initially tried to undertake this. They basically borrowed money from the British and the French to pay to build the Suez Canal. And then they failed to repay those loans. And the British and the French got together and said, OK, they owe us all this money, what should we do? And they said, well, let's just go take over the country. And they did. The British went to Egypt in 1882 and said, you've defaulted, we now own your country. And they were there for 72 years. The Panama Canal, the grandest of them all, 1879 to 1888, and then again, here again, the French actually tried to do it and they failed, and the U.S. stepped in and finished the job between 1903 and 1914. As we've already discussed this in connection with the Northwest Passage and cutting travel times through the Arctic. Well, the Panama Canal cut travel times enormously between Europe and Asia and the west coast of North America. one of the biggest reasons the French couldn't get the job done, anybody know? Malaria. The workers were falling dead from malaria so quickly that they couldn't keep going. And discoveries of ways to combat malaria, quinine and that sort of thing actually helped make it possible. But they also needed just more capital. You can see the scale of this undertaking and the use, again, of steam-powered engines to do the digging, trains to move the material back and forth, and build the locks necessary to operate the Panama Canal. All these things essentially becoming mutually reinforcing contributing factors in the evolution of capitalism. The profits from each of these enterprises could then be poured back into complementary activities and scaling up over and over and over again in one field after another. So you get the commercialization emerging out of mercantilism. We'll have to talk about that some another time. Paper representations. Again, all of these things mediated by these pieces of paper representing ownership in enterprise and rights to income. State bonds, for example, as I just suggested already. These paper representations were actually initially issued by states or municipalities rather than private companies to finance wars, rationalize revenue flows, underwrite various commercial endeavors. They only later evolved into what we think of as stocks, shares in private enterprise, what we're most familiar with today. Weber talks about this, how it sort of morphed from a state power into a private practice. Speculation is the key part is what becomes possible once those paper shares are tradable in their own right. And this is where Weber's going to say speculative crises are endemic to capitalism. You cannot have capitalism without having the risk of speculation, and you cannot have speculation without periodic bubbles popping. Okay? Irrational speculation, we'll talk later about the different ways in which these bubbles can burst. But the point I'm trying to drive home right now is basically you can't have capitalism without speculative bubbles. They go together. They are necessarily related to each other. And then this is the last slide pointing out the ways in which, in the case of sugar prices, you get speculations as a sort of characteristic feature. These wild price swings are a necessary feature. All right, sorry to rush. And we will watch a movie on Thursday, and then it will be spring break. Yay!